Sound is generated by vibrations. When someone speaks or roars, your throat vibrates, creating the sound. As that sound comes out the mouth, it spreads out in the air, and it's actually compressions and decompressions of the air. And when you're trying to record that, you need a microphone. iPods, iPhones, and recording studios all have microphones. And when that sound pressure wave hits the microphone, it causes a vibration in there which changes the voltage that flows through the microphone. So the audio signal, which is just air pressure, is then changed to a signal which goes up and down, depending on whether it's being hit by a pressure wave or expansion wave from the sound. That electrical signal or voltage travels through the wire to the computer. In the computer, it actually changes that signal to a digital signal. So when the signal is really high, it would do a really big number. When the signal is low, it would do a very, very small number. And of course, being a computer, it all works in zeros and ones. And so it actually just builds in numbers for the sound. And once it's in your computer, then you can actually edit it and change the shape and sound of the sound, because it's just numbers, and you can actually edit the shape of that sound quite effectively, or how loud or soft it is. And you also don't get any interference or from any distortion, because it's now digital and you can actually do whatever you like with it. It's time to learn some basic terminology when you're dealing with sound. A key thing to understand is what sound pressure level is, and that's actually the volume of a sound, or how loud it is. It's measured in decibels, dB, and the normal sound level you want to record at is about up to 0. Of course, the sound pressure goes up and down, or the volume, depending on how loud someone's talking, and when they're not talking, it goes down. So you want it to be maximum at about 0 dB. Sounds that are higher than that will cause distortion. And distortion just means the sound breaks down and it doesn't sound very good anymore. And so a lot of the time your sound is actually like -50 or -60 dB, and it fluctuates up and down. Some other terms you need to understand are what frequency is, and this one's used a lot. Sounds with a high frequency are sounds that vibrate very many times per second. So this waveform might look like that, whereas sounds that are very low, the tone is very low, the waveform is like that. And frequency is, again, how many times a sound, or the pressure varies every second. So that's actually measured in hertz, which is just the same as cycles per second, how many waves going out through the air per second. Closely related to that is the term wavelength. And wavelength's simply the actual distance between the peaks of the wave. It's not used as much in sound recording as frequency, so it would be that distance there. Again, not that important for our purposes. The other thing that's important to understand is what feedback is. Feedback is when the sound comes out from a speaker and then it's picked back up by the microphone, and it causes a cycle to happen. So initially sometimes you hear at assemblies when there's a high piercing squeal, and as soon as the sound goes out from the speaker, just imagine that's a speaker there. The sound goes out, gets picked up by the microphone through the amplifier to make it loud again, and back to the speaker. And so what happens is, as the sound goes out, it gets amplified, comes back out even louder this time, picked up by the microphone, and even louder, and this continual cycle happens, which is called feedback, and that causes that horrible squeal. So sometimes when you're recording sound, you've got to watch out for that. Now, if you could see all the sounds that go into a microphone visually, you can get an idea of what's actually happening. And usually people don't listen very carefully to sounds. They filter out what they don't want to hear. They're not actually aware of all the sounds that are around them. When you're recording with a microphone, it picks up everything. and doesn't discriminate like your ears do. And so often when you play something back, you'll notice all of the interference, all of the sounds you didn't want: birds singing, doors slamming, elevators moving, people walking in, talking in the background, or you might even have air conditioner noise. And depending on what you're recording, those are okay, or they may not be okay. When you're recording sound and music, it's always recorded in a soundproof studio, unless it's live, to cut down on all those sounds which would ruin the actual recording. But sometimes you want those recordings. If you're recording an interview outside, you want to hear a little bit of wind noise in the trees and birds, because it would sound a little bit odd to filter all those out, because the location and the sound wouldn't match up, and people would think it sounds odd. Or if you're in an office, you'd expect to hear some paper noise and phones ringing and printers printing in the background. Otherwise, the ambience of the room is different from what people would expect. And ambience is really just those surrounding sounds that are not what you're mainly recording. Obviously, the problem is sometimes those ambient sounds are just too loud, and then they interfere with what you're trying to record. Now, this little diagram here is an example of a recording made outside, and on this scale here, on the up and down scale, the Y scale, is the frequency, and you can see it's down from 689 hertz up to 4,823 here. So, well, actually from 0 hertz, which is no cycles at all, up very high. This is just recorded on an iPad outdoors. And what you can see in this region here on the low sounds, this is just wind noise. And the wind noise often causes quite a problem outdoors with microphones, and is a real killer for any outdoor project. So always try and do things on a quiet day. You can buy stuff to put on your microphone to reduce it, but it never totally gets rid of it. You can turn your back to the wind to help. What we can see here is someone talking, and you can actually see that frequency is quite low, but there's these other frequencies with the voice, which is why voice sound is so rich, because it actually spreads out over many frequencies. This sound here is bird sound, and you can see it's sort of going from high to low to high, high to low to high. So it'll be a sound like, and it's much higher than the voice. And again, you can see it tends to spread out a bit, and those are called resonant frequencies, which you don't need to know about, but this is really what sound looks like if you can see it on a computer screen. Now, when you're recording, you want to get the best sound possible, so it sounds really rich and you're cutting down background noises, especially when you're recording voice. So the number one thing you need to do is get close. The closer you get with your microphone, the less background noise you have, and the richer the sound. To do that, often you need to use an external microphone, because otherwise you might be pointing that camera right in someone's face and they might knock your block off. So having an external mic, well, you'll see on TV and radio they often have those little lapel mics, a little mic that's actually clipped to their tie. That's a good way of getting very close to the object or the source of your sound without being too close with the camera. There are also other types of mics you can use, and the one that you most often have in your iPhone and other devices is called an omnidirectional. And omni just means everywhere. Omni, and what that does is it picks up sound from all around the place. So that's not particularly helpful if you're trying to focus down on something. You can get what's called a, let's put this to the road. You can get what's called a unidirectional mic, and that tends to pick up signal from the direction it's pointing. So it obviously radiates out like that. So if your speaker's over here, it will still pick up sound that's over here, but it won't be as loud, so you can get a better signal. Some of the mics are called shotgun mics, and they have a very narrow range, and again it's to try and cut down the external sounds. And last but not least, it's good to listen to what you've recorded straight away. And if you can hear there's some sound which ruins the recording, just redo your recording.